Stricker, I'm going to talk to you about half-life today. There is a logarithmic formula that you can use if you're really good at Algebra 2 for half-life, but I'm going to teach you the old school way. All right, and the old school way is this. In every problem you get, they're either going to give you 2 times in one amount, and you have to solve for the other amount, or they're going to give you 2 amounts in one time, and you have to solve for the other time. So those are the things that you're looking for. The time units are going to be in days, minutes, or years, something that deals with time. The amounts are going to be usually in grams. And so we're going to look over this worksheet right here. All right, so you'll be able to see that on Blackboard. But the first thing, or Schoology, sorry. Okay, the first thing it says, how much of a 100-gram sample is left after 8.10 days if its half-life is 2.70 days. So it's giving me the original amount. It says 100 grams. Okay, so that is my original amount. We always set the original amount, okay, to 0. All right, so it's 100 grams. All right, it's asking me for my ending amount, but I don't know that until I know my n, which is the number of half-lives that it's going to go through. All right, and half-life is the amount of time it takes for half of the material to decay. It did give me 2 times. It gave me 8.10 days as the total time, and it gave me the time for one half-life was 2.70 days. Okay, so it gave me 2 times. This is obviously the total time, it's the larger one. This is the time for one half-life. You divide that to get your n. Well, in this case, 8.10 divided by 2.70 is going to be 3. So that means that I'm going to go through 3 cycles of half-life. All right? So all you do is you take 100, which was set to 0 half-lives, and you divide it by 2, so I get 50. Then I divide that by 2, and I get 25. I divide that by 2, and I get 12.5 grams, and that is my answer for how much I come up with. All right, so if it gives me the times, I can always solve for n. If it gives me one amount and I know what my n is, then you just half it to get to that. All right, we're going to do number 2. It's a little bit different. All right, number 2, it says a 50-gram sample decays to a 12.5 gram sample. So now it's giving me 50 grams is my original amount, so I set that equal to 0. All right, and then it takes it down to 12.5. Well, I have to determine how many cycles it went through to get my n. So 50 divided by 2 is 25, so that's 1 half-life. 25 divided by 2, oh, that just happens to be 12.5. So my n equals 2. All right, so then I'm going to plug that in here. So if my n, it's 2, and so 2 equals the total time, which it told me was 14.4 seconds, divided by the time for 1 half-life. All right, so to be able to solve for this x, right, you have to get x on top by itself, right? So if my x is here, I have to multiply both sides by x, and that gets the half-life off of here. Divide both sides by 2 to get it by itself. So it's going to be 14.4 divided by 2, and my answer for half-life is going to be 7.2 seconds. So you can see in the first problem they gave me 2 times in one amount. In this problem they gave me 2 amounts in one time. So that's the formula you're going to use to solve for those. All right, we'll do another one here. It says the half-life of potassium 42 is 12.4 hours. So that gives me the half-life is 12.4 hours. How much of a 750-gram sample is left after 62 hours? So my total time is 62 hours. So 62 divided by 12.4 is what? 5, I think. Right? Yeah. 5. It's always going to be a whole number too, by the way. So when you divide the top by the bottom, they're going to give it, it's going to be a whole number. All right, now it did tell me that it says how much of a 750-gram sample is left. So my zero, my original amount, is at 750 grams. All right, so My n, remember, is the number of cycles of half-life that it's going to go through. So if it's 5, I need to do 1, 2, 3, 4, and 5. All right? Now, Riley, you've got a calculator, so I'm going to have you help me out with this. All right? So 750 divided by 2 is what?
375.
375 divided by 2 is what?
187.
187.25. Okay? Divided by 2.
93.75.
93.75 divided by 2.
46.875.
46.875 divided by 2.
23.4375.
So 23.475 grams. That is my answer of what is left over after 62 hours if the half-life is that, and I started that. All right? Now we're going to do, now you notice as you go down, you are dividing by 2 every time. So with every one, you start at 0. The most common mistake people make is they start at 1 and then it gets messed up. You start at 0 because that's your original amount. O and original, okay, look the same, right? Original and 0. So make sure you remember that. Now, let's skip down to number 6. On number 6, you're trying to find out how much was in the original amount. Okay? So, it says there are 5 grams left over. 5 grams left over after 40.35 days. So my total time is 40.35. It says how many grams were in the original sample if the half-life is 8.07 days. So, if my half-life is that, and my total time is that, then my n is going to equal what? 40 divided by 8 is 5, right? So my n is 5. So that means it's 5.0 grams after 5 half-lives. So then I go to 4, 3, 2, 1, 0. Because remember, 0 is my original amount. And now, before I was dividing by 2, but what do I need to do now? Multiply by 2, because I need to find out what was in my original sample. So I go from 5 to 10 to 20 to 40 to 80 to 160 grams is my original sample, and that's my answer. All right? So that's a problem right there that you're definitely going to have to be able to do. If they give you the ending amount and you're finding the original amount, you have to first find the n by using the times. Okay? Total time divided by time for 1 half-life gives me that. Then you set your ending amount equal to n, and then go 4, 3, 2, 1 up to get to 0, and then you're multiplying by 2 on each. All right? So hopefully that'll help you out in half-life in your problems.